with the inverse Laplace transform. Okay, so previously what we have done with is transforming a function of t to a function of s, right? So we transform f in terms of t to transform. Kenapa dia yang dalam lobby ni? Okay, we transform function in terms of t to function in terms of s. We apply Laplace transform. Okay, now we want to go back from fs to ft, so we need to apply inverse Laplace. So I believe some of you have seen the video, even though it has no sound, but I think you can get some input there. Okay, so in order to get ft, we have to apply inverse Laplace. So why we need to transform and inverse transform again? Because our aim is to find the solution of dE. Remember, we have a function of ft. We transform to get fs, and then we find the solution in terms of s, and then we inverse transform to get the solution in terms of t. Okay, so this is what we are going to do. So before we can proceed with this, we have to understand how to transform and how to inverse transform. So basically, there is no exact formula on how to inverse transform, but you need to understand how can you transform first. What are the nature of the function once you transform? What are the properties used? Okay, basically from the table of transformation or from the types of function itself. Okay, the type of function which is which you have learned previously is unit step function, direct delta function, and then all the properties. All of those things is going to be used in order for you to understand on how to inverse transform. All right, so let's say you know that when your function is equals to 5, then your fs equals to 5 over s, because when you have a constant, then the function is a over s. Now, your fs is 5 over s. So in order to get ft, you need to inverse transform this fs where you have 5. So from 5 over s, you will get 5. So that's why you have to understand the nature of the function. So this comes from constant. So you will get constant. Okay? Clear not? So that one is for constant. So this one. Okay? Now, that one is from the table of transformation. You have to understand whether that function has s to the power of something as the denominator. Then you know it comes from t to the power of n. You have the function of s in terms of s minus a as your denominator. Then your function is in terms of exponent. Okay, so that's why you need to understand the function first. Okay, that one is from the table of transformation. Or you can also use the properties that we have learned. We have what? First shifting. We have special types of function, Heaviside function. This is second shifting. This is direct delta function, and this is the properties of direct delta function. And then we have linearity, and then we have multiplication by Tn, and so on. So you need to understand all of those things before you can do the inverse transform process. Okay, so this is inverse transform of 1. How can the inverse transform of 1 be direct delta function? Because transforming direct delta function equals to 1. Where is direct delta function? This one. Here, right? Transforming direct delta function equals to 1. So inverse transform of 1 will give you delta function. Okay, clear not? This is how you transform. Okay, any question? Very easy, right?
这客房的是
Okay, any question? All of you understand? Are we good? Okay, guys, do you understand this? All right. What about the rest of you? Okay. At least you can show some emoji, right? Please respond. Otherwise, I don't know whether you understand or not. Okay. So now let's try this example, which is the same example that we have been used in the video. Okay, so now we have fs equals to 4 over s squared plus 9. Okay, so you need to match with the table of transformation first, which form that is mapped to the function given here, as you can see here. So we have here, we have s squared plus with some value, and we have value here. So as you can see, s squared, this is not s squared, so this is s squared, this is s squared, this is s squared, this is s squared. Then we have plus there, so plus this one, and we have value there. So the most suitable form is sine 80, but you have to make sure this is a and this is a. So now this fs is in terms of 4 over s squared plus 3 squared, because here you should have a squared, means that the value here should be 3. Okay, so it can be written as 3 over s squared plus 3 squared, but you need to remain 4 there, so you have to multiply with 4 over 3. Okay, we don't want to change the function. Okay, so we have to do some modification. Okay, then in order to get ft, what you need to do is to inverse transform of fs. Okay, where inverse transform of fs here is 4 over 3, 3 s squared plus 3 squared. And by linearity property, you can put 4 over 3 as a constant outside. So you can inverse only 3 over s squared plus 3 squared, where this is mapped to a over s squared plus a squared. Now your a is 3, so you can get 4 over 3 sine 3t. All right, so this is how you inverse transform. Is that clear? Okay, now let's try B. You have fs equals to 1 over s to the power of 5. So now s to the power of 5 is mapped to which form? The more suitable form comes from here, right? S to the power of n plus 1. So this is mapped to n factorial over Sn plus 1. And you know that n plus 1 equals to 5. So n equals to 4. Okay, so you have to have, in order to get this ft, you have to have 4 factorial here over s4 plus 1. But you want to remain 1, so just multiply with 1 over 4 factorial. Is that clear? So you can have your ft by linearity, putting 1 over 4 factorial outside, and then just focus on inversing 4 factorial over s to the power of 5, which give you 1 over 4 factorial is 1 over 24. 4 factorial s to the power of 5 n equals to 4, so t to the power of 4. Is that clear now? Any question? Okay. All right, now let's try C. How can we inverse C? So first, which form is the most suitable? We can map to C here. 6 over s minus 1 to the power of 4. Have a look first. We have a table of transformation. We have all the properties and types of function here. So s minus 1 to the power of 4 is mapped to what? Not shine, because shine here is s squared. This one is s minus 1 bracket to the power of 4. Okay. We cannot use this. This one also cannot. This is only s minus a, cannot. This is s squared, this is s squared, this is s squared, this is s squared. So all cannot from table of transformation. So take a look at the properties. This is direct, this is direct, this is heaviside, this is heaviside. So all cannot. So what is the most suitable form here is fs minus a. Okay. So from here, this fs equals to 1 equals to 6 over s minus 1 to the power of 4 is mapped to fs minus a, which inverse transform of fs minus a equals to EAT ft. So as you can see, this is actually fs minus a, where if fs minus a is 6 over s minus 1 to the power of 4, then your a equals to 1 here. And if a equals to 1, then fs equals to 6 over s to the power of 4. So from here, you can inverse transform basically based on the table. And as you can see, this is mapped to n factorial over Sn plus 1, right? Where n equals to what? N plus 1 equals to 4, so n equals to 3. So we can get Ft. So Ft equals to just inverse 6 over s to the power of 4. Okay, where s to the power of 4 here, n equals to 3. So inverse transform 3 factorial over s to the power of 4, and 3 factorial is equals to 6, so no need to modify anything. Then this one is t to the power of 3. So now, when it is fs minus a, we want to implement the inverse process, we will get exponent atft. So ft equals to inverse transform of 6 over s minus 1 to the power of 4 will give you exponent atft, and a is 1, ft is t cubed from here. So this is how you inverse transform. Right? Clear now? Any question? Okay? Want me to repeat? All right, so first we have fs minus a. Sorry, we have fs, right? But you can see it is mapped to fs minus a because there is no form that can be matched to this. All right, so actually this 6 over s minus 1 to the power of 4 is fs minus a, where you can see here s minus 1 is s minus a. So a equals to 4. A equals to 1. All right, then when a equals to 1, so basically from here, you know that fs equals to 6 over s to the power of 4. So from here, you can inverse one by one of fs first. Okay, so this 6 over s to the power of 4 is actually mapped to n factorial over s to the power of n plus 1, because this is 4. So when this is 4, then n plus 1 is 4, so n equals to 3. So you know that this map to what? Ft equals to t to the power of n when n equals to 3. So in order to get Ft, we inverse 6 over s to the power of 4, where you know that when n equals to 3, Sn plus 1 is S4. So here should be n factorial becomes 3 factorial. And fortunately, 3 factorial is 6. So no need to modify anything. Then inverse transform 3 factorial over s to the power of 4 is 3 cubed. So we get Ft from this Fs. Okay, now you know that this is Fs minus A, and if you inverse Fs minus A, you will get exponent ATFT. So you already have your A, and now you already have your Ft. So just substitute. So in order to get Ft, when you inverse transform 6 over s minus 1 to the power of 4, it is exponent ATFT, where exponent A is 1, Ft is t cubed. So this is how you obtain your Ft. Clear not? All right. So basically, this comes from table of transformation. Example A comes from table of transformation. B also comes from table of transformation. And C comes from the properties first. Once you understand the properties, you can just inverse transform directly from table of transformation. Okay, so you need to understand the form of the function, the nature of the function itself. All right, so let's take a look at another example. So you need to understand this. The table of transformation here is given in your exam, so don't worry. Okay, so you have to understand why, how can you use it. All right. So let's try another example here. Example 18. So now this function is mapped to what? Oh, okay. From the table of transformation, there is no s minus something squared, right? So this is also mapped to f s minus a, where a here is 2, right? So now f s minus a equals to 2 over s minus 2 squared plus 9. Okay, so from here you know that a equals to 2. Then fs equals to 2 over s squared plus 9. So from here you can find your ft by inversing 2 over s squared plus 9. Okay, here should be s squared plus 3 squared. So when it is 3 here, this one should be 3, but without changing the function to remain 2, multiply with 2 over 3. Okay. Okay, which is equivalent to 2 over 3, 3 over s squared plus 3 squared. So inverse transform 3 over s squared plus 3 squared becomes what? Okay, sine 80, so sine 3t. So here we have 2 over 3 sine 3t. So now you have your A, you have your ft, and you know that when this is fs minus A, in order to get ft, it is inverse transform of fs minus A, which is equals to exponent at ft, and you know your A is 2 and your ft is 2 over 3 sine 3t. Is that clear? So just modify here. Okay, clear not? Understand or not? Okay, if you understand this, why don't you try B? Try first. After this, we discuss. Which form is mapped to the function given here? Okay. First, you have to take a look at the table of transformation and also the properties, right? So there is no function which has the coefficient of s, okay? S here stand alone, s to the power of n plus 1, s minus s squared, s squared, s squared, s squared. So this one is s, also s, also as, and so on. So there is no coefficient of s in the denominator of function s here. So what we have to do, first you need to factorize. Okay, so now this fs is now can be factorized or simplified to 2s plus 5 over 2 cube, right? Where you can put this 2 as 2 cube, s plus 5 over 2 cube, where this is 3 over 8 s plus 5 over 2 cube. Okay, so as you can see, now it is s alone. And this is quite identical with this, s minus 2 squared, s plus 5 over 2 cube. So this can be mapped to fs minus a. Alright, because in the table of transformation itself, there is no s plus with something to the power of 3. So we can conclude that this is just a function of s minus a. So you have to put 2 in terms of minus there. Okay. So now this can be written as Right. So you know that, then this is Fs minus A. Where A equals to -5/2. Okay, so when A equals to -5/2, and this is Fs minus A, so Fs can be written as 1/s cubed, right? So this is in terms of S minus A now, in terms of S alone. So this is mapped to what? N factorial over Sn plus 1. Alright. Okay, now when n plus 1 is 3, so n equals to 2. Then this function of S can be inverse transformed okay, where this can be written as S cubed, S cubed. So what? This is 3 and is 2, so this one should be factorial, but we have 1 here, so multiply with 1/2 factorial. Okay, up to this point, are you following this? Understand or not? Okay, now we want to inverse. So this is 3/8. This is 1/2 factorial is 1/2. So we just inverse 2 factorial over s cubed, which give you what? 3/16 t squared, because n equals to 2. Okay, when n equals to 2, so t to the power of n, t squared. Okay, now that is ft. So from here, when it is mapped to Fs minus A, so inverse transform of Fs minus A is equals to exponent At Ft, where A is what? A is exponent -5/2t and t is 3/16 t squared. Okay, same right with the answer? Okay, clear or not? Anyone has question? Anyone has problem? It's okay. You can ask. Don't be too shy. This is the learning process. Try to understand first. We start with this. And then we simplify. And then you know that this is in terms of Fs minus A. So we know your A. Once you know your A, you can have your Fs and map to table of transformation to get F. So this is your Ft. Then inverse transform of Fs minus A should be exponent ATFT. So just substitute what is your A and what is your Ft. Okay, clear now? Try to understand first. Okay, any question? All of you understand this? All right, good. Can we proceed? I don't know whether you understand or not, because only at least 3 to 5 of you respond. I don't know about the rest of you. Okay? All right, you can proceed. Thank you. Okay, next is we can also, okay, just now we have done with finding inverse transform directly based on the table of transformation and also understanding the properties and types of function. Okay, so we have to know the function of s given map to what kind of function from the table of transformation or from the properties that you have learned. Okay, but basically maybe sometimes a function cannot be as simple as that. So you need to do some simplification. Okay, one of the methods to simplify the function is by using partial fraction. Okay. Okay, one of the method to simplify is by using partial fraction. So now I believe that all of you have learned about partial fraction, right? Okay, so look at this. Okay, now let's say you have this kind of function where, as you can see, there is no form of function is suitable with this function directly based on the table of transformation and also from the properties. We have x squared minus s minus 6. There is no such function in the table of transformation. So what we need to do is to simplify. So in terms of fraction, we can simplify it by using partial fraction. So before you simplify by using partial fraction, you have to know there are types of denominator which can be used to simplify the fraction to partial fraction. Okay, when the denominator is single linear factor s plus a only, so the partial fraction is a over s plus a. When it is a repeated factor, s plus a squared, then we can use this partial fraction for repeated factor. A over s plus a plus b over s plus a squared. Same with up to cubic. We have up to c over s plus a cubed. So we repeat about 3 times. Okay, and then when the denominator is a quadratic, then the numerator is a linear. Okay, and when the quadratic denominator is in terms of power 2, power 3, it is a repeated factor, then you just can apply the repeated denominator. So for this one, okay, 3s plus 1 over s squared minus s minus 6. So in order to know whether the function is linear factor, quadratic factor, and so on, you need to simplify the denominator. Basically, you know that this is a quadratic. You just can factorize by using your calculator. So, you know, from here, from this example, as you can see here, okay, this can be simplified to s plus 2, s minus 3, where you know that this s plus 2 and s minus 3 is a linear factor. So you can decompose to the partial fraction of a plus b over s plus 2 plus b over s minus 3. So from here, you can solve this a and b by comparing left-hand side and right-hand side and find the value of a and b. So now, this function now can be simplified to this once you obtain A and B. So this is your A, this is your B. So instead of inverse transform this, now we can inverse transform the partial fraction that we obtain one by one. So basically, from the linearity properties, we can inverse transform one by one here. So 2 put outside. So this is mapped to what? 1 over s minus a, where we can get ft here equals to exponent minus 2t plus 2 exponent 3t. Is that clear now? We have to simplify. Okay, how to simplify? We use partial fraction, and once it is simplified, you can now map to the table of transformation of the properties. Is that clear now? How to simplify? Take a look at the denominator. Use quadratic factorization if the function is quadratic, and then just can proceed with the partial fraction. Find the value of constant A and B then. Okay, clear now? Any question? If you can manage to find A and B, simply just like this, then no need to write one by one, step by step. Okay, just identify where does the value comes from. At least the steps are there. No need to do it one by one. Okay. All right, clear? So let's take a look at the example here. Okay, now dealing with the fraction, of course, you have to factorize. If you cannot factorize, you can try to use completing the square method. Okay. Okay, let's try this 3 example. Okay, for this one, it is easy for you to factorize because this is just a linear factor here, right? Okay, try this one, 20 and 21. The answer is there. Okay, for 19, you just factorize. Okay, you just factorize here. S squared minus s minus 12 become s plus 3, s minus 4. So this is a linear factor. Then it can be decomposed to partial fraction. So find A and B. Okay, try to find A and B by your own. And then once you got A and B here, then you can inverse transform one by one based on the table of transformation. So this is easy because this is just the linear factor. So now for the example 20, it is a linear factor together with the quadratic factor. So the denominator is A and also BS plus C. Okay, try to solve this and this is the answer. And this one cannot be factorized, so we can use completing the square. So try it. If you have problem, you can ask. Of 4s squared minus 5s plus 6 over s plus 1 s squared plus 4. Now we can simplify to A is 3. B is 1. And C is 6. Minus 6. So you can inverse transform 1 by 1 here. Okay. So once you understand how to transform directly based on the table of transformation of properties, you can inverse transform this 1 by 1. So these 3 put outside. This is already simplified. Okay. And this one is 4. So 2. So 2. 2. Right. Which is 3. Okay. Then you can directly transform to get ft. This is 3. This is exponent minus t. This is cos 2t, and this one is minus 3 sine 2t. Same, right? All right. Okay, clear or not with example 20? Any question? So the problem here is to find the value of constant there. Once you can get the constant value, then you can simplify and just map to the table of transformation or properties. Okay? So, example 21, any problem? I hope everyone can do this. Anyone has question? Or you have problem with finding the answer here? Any question? Why today so silent? Do you understand what we have been doing just now? Okay, so example 21. All of you got the answer or not? No question. Okay, good. Okay, so you got the answer, okay? So I believe no problems with finding, with simplifying the function by using completing the square, right? So after completing the square, this is the process. This one can be simplified to this, okay? Where it is mapped to fs minus a here. All right, so you just need to simplify this in order to map with fs minus a. Means that every s here should map to s minus a. Okay, now this one is s plus 1. Okay, now we want to inverse transform to s minus 3 over s squared plus 2s plus 17. So by completing the square, we just simplify this to 2s minus 3 over s plus 1 squared plus 16. So this is s plus 1. Then we can map to fs minus a. Okay, but we have to have some modification here. So the denominator here should be s minus minus 1 squared plus 16. So this s should be s minus 1 also. Sorry, s minus minus 1 also. 2s plus 2. This one is minus 3. So you should have with minus 5 here, right? So when you expand, you should get 2s minus 3 again. So 2s plus 2 minus 5, so becomes 2s minus 3. So now from here, as you can see, this is fs minus a. where A equals to -1. So when A equals to -1, this Fs minus A now can be turned to Fs by 2s minus 5 over s squared plus 16. Right, so in order to get Ft, you can just inverse transform this one by one. Right? So this 2 put outside. This one s squared 16 is 4 squared is cos 40. This one is 5. This one is 4 squared. So you should have what here? 4 over s squared plus 4 squared. But this is 5. Then just put 5 over 4. So minus 5 over 4 sine 40. Okay. Same. Then this is your Ft. And remember, this is mapped to Fs minus A. So inverse transform of Fs minus A should be exponent ATFT. Now become exponent minus T because A is -1. Ft is 2 cos 40 minus 5 over sine 40. Okay. Right. I hope everyone can understand this. Any question? So from 1 to 10, where are you just now? By using this partial fraction and also table of transformation together with the properties. How can you inverse transform? By table, by properties, by types of function, and now by partial fraction. So from 1 to 10, guys, where are you? One, two, three, 4, 5, 6, 7, 8, response 9, 55. Why so sad? Nothing. Okay, at least you got half of it, right? But after this, you can try to do the practice, to do the tutorial. Okay. All right. So thank you for your response. At least I know you are listening, not just for the sake of attendance. Okay. Can we have another one? This upcoming Sunday is holiday, right? So let's just proceed with another topic. Still, we are going to find the inverse transform. Now we have the theorem. Okay, this theorem is quite easy. So don't worry. Okay, now let's proceed. So here, still we are doing the inverse transform. Now we want to find the inverse transform by using convolution theorem. So where can when can we use this theorem? Because not all function can use this theorem. Okay, just like before, we just use the table of transformation. No need to use this theorem. So when can we use? When there is a combination of two function of fs and gs. Okay, but if you have one function, let's say 1 over s minus 4, then another function is 1, right? So you can also use this theorem. So basically, this convolution theorem is used when there is two function comes together of fs and gs. Then by convolution theorem, the inverse transform is equals to integrating from u to t fu gt minus u du. Now let's take a look. This is quite easy. Let's take a look at this example. We have 1 over s times s squared plus 4. So as you can see, this is a combination of two functions. Okay, so you can say that fs equals to 1 over s, gs equals to 1 over s squared plus 4. Okay, so now when your fs equals to 1 over s, because we want to match with this theorem, so we need to inverse transform one by one first. When fs is 1 over s, what is your ft? Ft equals to what? Ft is inversing 1 over s here. So what is Ft? Inverse transform of 1 over s equals to what? From the table of transformation. A. So A is a constant, then 1, right? Okay. When Ft equals to 1, then can I say Fu also equals to 1? Is it? Because it is a constant. Clear now? Understand or not? For this part. Okay? Because this is just a constant. All right. Let's say your Ft equals to 2t, then or your Fu equals to 2u. So just change of variable. So there is no variable involved here. There is constant. Then when Ft equals to 1, Fu equals to 1. Okay, settle with Fu here. Now, Gt minus u. So you have Gs. Gs is 1 over s squared plus 4. So you can find your Gt by inversing 1 over s squared plus 4. So how? This is s squared plus what? S squared plus a squared. So this one should be 2 because this is 2, but we have 1. So just multiply with 1 over 2, put 1 over 2 outside. Right. So you will have 1 over 2 sine 2t. Okay. So when gt equals to 1 over 2 sine 2t, then gt minus u equals to what? What is gt minus u? 1 over 2 sine 2 t minus u. Okay, clear not? So, inverse transform of f as gs now can be written as integrating from 0 to t, fu is 1, gt minus u is 1 over 2 sine 2t minus u with respect to u. So 1 over 2 times 1, just put 1 over 2 outside. So integrate sine 2t minus u with respect to u. Okay, can you integrate this? What should you get? So the answer here is the product of inverse transform of Fs and Gs. Okay, try to integrate this. Direct integration. What 5? Understand or not? Okay, all of you got this, eh? All right. Okay, let's try this example. What's your question? Of convolution theorem. So as you can see here, this is a combination of Fs and Gs. So you can choose either function for your Fs or Gs. It's up to you. All right. So this is 1 over s, 1 over s squared minus 4. This is 2s over s squared plus 4. And then you can choose 2 over s squared plus 4. And another one is s over s squared plus 4 because this is squared here. Then you can choose 1 over s to the power 4 here as one function. And another one is 1 over s squared plus 16. So you just can choose one Fs and one Gs there, and then find your Ft and GT minus U, and then just substitute to the theorem. So this is how you use the convolution theorem. Okay, any question? Right, I hope you can try this. Let me give you the answer here. A is there, the answer of A is there. All right, you can try. So the method used here is basically based on integration only. Once you substitute, what you can do here is to integrate. That's why it is important for you to have a strong foundation on that. Any question so far? Everything's good? Anyone has question?